And if we don't find anything, it's just bits. Okay. So okay, so we'll run this. It's taking its time. Okay. Okay. It's 3 bucks. Okay.
Yes, it should be.
Okay. Cloud get of this thing.
Yeah, that's just that expression because in case I need to change it, and indeed I did a little earlier today.
Okay. So, you're saying that basically I can submit a big thing. Okay, so let's take a look at how I would submit, because I've got to load a packlet onto, so we've got to bundle up something that can run this whole job, right?
Right.
So, we've got a bunch of initialization code to run. Let's try to, Max, let's try to run a job that corresponds to one of our search jobs. That seem reasonable?
Okay.
Okay, so let's look at what we actually need for that. This is what we'll ultimately want. Now, does that thing have any parallel processors or not? How many?
It can. I don't have it set to, and even if I did, I don't know if Wolfram does that work with Wolfram Engine? I guess it would.
Don't know.
It probably would, but I have the jobs configured to just have one vCPU each.
Okay, so what we're doing here, let me show you what this does, okay?
Mm-hmm.
Look at that thing. It's the Klingon battle cruiser of a universe. Okay, well, maybe we can look at this set. So let me show you what we would typically want to do. How expensive is the data transfer? In other words, okay, so here, this says, you see what it's doing? It says parallel map monitored. So that is going across, it's running across 1,000 1,000 universes here, okay? It's randomly picking 1,000 universes. Now,
yeah.
Everything is parallel here. So the question is, how would we do that in this case? Will we run it on different machines, or what will we do?
So what you want to do is run 1,000 of these things, right?
Actually, I want to run 1,000,000 of them.
Okay, but I mean, is it like, is this parallel map monitored thing? Do you want to run that 100 times, like in 100 different jobs?
Okay, so listen. This is stateless. Okay, this thing here. Every time I run this, let me show you what it does. Okay. Every run of that thing just goes crunch, 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 and produces a result.
Yeah.
Okay. That particular one was extremely boring. Okay. Then this thing here, WMF filter 4, WL filter 4, why is this ground to a halt? Okay. It says died fast for this one. Okay.
Yeah.
What is going on my machine? Look at this. You don't have a bunch of dynamic stuff in your notebook here, do you?
Mine? No. There's nothing dynamic.
Okay, so you see the point. We're going to run these, a million of them. We're going to look to see whether they come back as maybe interesting. And if they do, we'll send them back. And if they don't, we won't.
Okay. And if I may ask, why are you doing random things instead of enumerating like sequentially?
How many do you think there are? How many do you think there are?
I don't know.
Yeah.
But I mean something to make to, I guess the chance of running the same one twice is considered to be 0.
Yeah, there's like 10 to the
Okay.
15 of these or something.
Okay, fine.
The,
Okay.
I'm going to restart this process. Look at this. This thing is going crazy. I think I need to restart here. My God, what's it doing? This is really odd how slow this is running. By the way, Max, we shouldn't forget to look at what Rob did.
Yeah. Speaking of distance matrix, one way we can try computing it is by distance to the shared ancestor in the causal graph.
Oh, that's interesting.
I think that's closer to a real life distance than the network distance.
Okay, let me just do my. What is that shit? Photo analysis ID is running on. Okay. All right, let's rerun this. Okay, so let me show you what we have to do to get the thing to. Okay, so we have physics project initialization. Only some parts of this are relevant. So which version of Wolfram Engine is this running? Is this a 12.1?
12.0.
How is that?
Or 12.0.1.
Max, how is that going to work? We could run this version, I guess. Do you think?
Probably not. I don't think I updated it to work with max vertex degree and such.
Okay. Well, if there's a 12.1 Wolfram engine, I can put that up. I don't know where that would be. I didn't see any. I didn't see any on the build monitor, but I don't really know where to.
Well, look there. That's the only place it would be.
I mean, I do have a Docker image with Wolfram Desktop 12.1 in my private repository that's useful.
Okay, I can try that. I mean, that just, well, it'll work. It's just way bigger than just the engine.
Yeah,
But
it is big.
oh, wait, no, Wolfram engine.
I mean, I can also recompile it with the latest version, but I'm not sure how well it's going to work.
Yeah, there's no Wolfram engine 12.1 for Linux builds on Build Monitor.
Can't we just take the Docker images, rip out all the documentation and things, and just run?
Yeah, we can try that. And I mean, I will.
Well, what's the easier path? Max, what is the easier path? Is the easier path to backport the vertex degree stuff to the 12.0 case, or is it better to?
I can put together a Docker image for 12.1. I just can't do it right now.
No, I understand, but Max,
Okay.
what is the?
Well, right now it will be easier to compile it for 12, but continuing supporting version 12 indefinitely is definitely harder.
Right. Although when we release this, people will want something that works under 12 probably, because 12.1 won't yet be released.
Well, that will be a big problem. When is 12.1 going to be released?
Sometime in January, probably.
Well, so it's about the same time.
Yeah, but it won't be exactly the same time.
Well, can we launch the physics project after that then?
No. I don't think so. I don't want to do that. I'm not going to wait with that dependency. Oh, we can tell people it's not ready yet. It'll be ready in
But the work to make it work on version 12.0 would probably take more than a week or two. Because I will have to re-implement coordinate constraints somehow.
Which you're using for the hypergraph plot.
For rule plot, yeah.
Well, we need to make sure that it fails gracefully in 12.0 so that we can tell people it's for 12.1.
Well, we could just add to packet info temp saying it's 12.1.
Well, do that. Please do that.
Sure.
Okay. All right. So basically, we need a 12.1 Wolfram engine, or this is not going to work. We also need to load in a bunch of this stuff. Well, this stuff we don't need to load in. We need to load in some of these things here. So what should I do here? Should I make a package that we can load in to, right? Did you understand what I'm asking?
Yes, yeah, I understand. There are multiple ways you could do it. If it really is just like definitions like that, you can just stick those in the second argument to remote submit, because it will gather up. I mean, you don't even have to put them in there. It has include definitions to true, so it will it'll pick up the definitions required by the code that's in the second argument. But I mean, for structuring and extensibility, it might be best to put them in a package file that gets.
No, it's okay. I mean, it's okay. Let's try, but wait a minute. We have to have the packlets here. This packlet needs to. This is the problem, Max. I mean, so there's a bunch of things that come from the function repository, right? That are.
Well, the package is not a problem. You can just pull it and install and build it on you know, on the
You
Docker
can
image.
just, well, if it's, is it on the Packlet repository, or will it be? Because you
No.
can just do Packlet.
No, it's
Okay.
sitting here with a Packlet install from a specific place. Unless Max has a copy of it. I mean, we can push this Packlet to the cloud and pull it from there.
You can
Yeah.
just clone it from GitHub and build it. This way it will always be updated.
Okay,
Well,
then give, yeah.
No, I can do that, but it's not. I mean, the Docker image isn't supposed to be something that gets modified. It's supposed to just be the engine, and all that everything you need to do, you do inside your job
All right,
code.
let's try to do it. Let's try to do this let's put the thing in this Packlet, okay, the 12.0 Packlet into, and let's just see if we can get anything to run. Okay? Okay, so I mean, clearly this isn't going to work properly without a 12.1, without the 12.1 Packlet and a 12.1 engine. Make sense? Right?
Yeah.
You understand? So
I do, yeah.
Yeah, right. So Max, that's what we have to, I mean, I guess for you, it's just delivering, if you can, somebody's, I mean, do you think you can get, Jesse, a Docker image with a bunch of all the random documentation stuff taken out?
Yes, I can do that.
Okay, well, so Max, how, do you want to get the Docker image from Max, or do you, what's the idea?
I'll put something together. I can do that myself. Now it would be useful to know exactly what build I should work from, if that matters.
The latest
Okay.
one.
Okay.
Okay, then Max, you need to specify where this Packlet comes from. Max, are you still there?
Well,
Hello?
the easiest way is to just build it. Then we don't need to manually update it all the time. And it takes about 6 seconds. So presumably
Okay.
it's much faster than just downloading the Docker image.
Build it when? Build it once when he builds the Docker image, right? When he builds the thing to put in AWS.
No, because then it won't auto-update.
I don't want it auto-updating. We don't want it auto-updating, right? Jesse said you can't auto-update this. We don't want it auto-updating. It's not a good idea.
No, you can build it before every time it's launched.
Seems like a
Which
dumb
I
idea.
suspect is going to be much faster than downloading the Docker image.
It's not, the Docker image. All that's in the Docker image right now, and all that should be in it, is the Wolfram engine, and all of your user code. It's a little over a gigabyte, I think. But the way that it works on AWS, though, is that the image gets cached in each instance that jobs run on, and while an instance is active, before it gets, they will get eventually terminated for inactivity if there haven't been jobs submitted in, it seems like 10 or 15 minutes or so. But while the instance is active, that image is cached on the instance outside of any of the jobs. So when you submit the first job and it needs to launch up an instance, that takes a little while to launch the instance and to download the Docker image. But subsequent jobs that run on that instance execute very quickly because the image is already cached. So the downloading of the Docker image is not an issue. But
is there any chance you can cache dependencies over there? So that you build you rebuild set replace, but only if it's updated.
Well, why can't it just be on a Packlet server or in a cloud object that gets fetched? That would be quick.
Yeah, but then you have to update this cloud object all the time.
Well, you'd have to update it somewhere anyways, right? I mean, are you suggesting pulling from Git?
If you do that, it's it's updated automatically. You don't need to do anything.
Okay,
at all.
I mean, I mean the code in it could pull from Git. I mean, it would have to be GitHub, not Stash, because the jobs aren't running behind the firewall.
Okay.
So
So
yeah, it is on GitHub.
Okay, well, it would be so inside the second argument to remote submit, you do like URL download of whatever the URL to the zip file
wait,
is.
are you telling us something, or am I supposed to be typing what you're telling me?
I'm telling you something, and I probably don't need to. So, but yes, that can be done.
Okay. Okay. So what okay. So what is the conclusion here about what we can do?
Well, for set replace, each job will download the code from GitHub and I guess put it in a directory that can be loaded from.
Okay.
And then just those function definitions. I mean, those just have to sit in whatever notebook you're doing the remote submit of the job.
Well,
in.
they have to be alive in that session, is what you're saying.
Yes, they have to be alive in that session. Or I think it might be better to just put them inside the second argument to remote submit. Have a giant second argument that has. Well, okay, it's your choice, but
I wouldn't have a giant second argument. I don't want to package them that way because they're going to change. So
okay. Well, you could put them in a separate file that gets loaded via get. I mean, if you want to just.
I don't want to put them in a separate file.
Okay.
They're being managed in a notebook, so they'll get automatically pulled in by full definitions, right? So let's just be happy.
Okay.
Oh God, look at this. This is so annoying.
Well, actually, since we are going to have it in the function repository anyway.
Yeah, but we're not going to have it immediately this weekend there, unless you know how to put it in there.
Yeah, we would.
Do you? Do you now know how to put it in there or not?
I think I do.
Okay. What? Well, so you should go ahead and do it because it will be super useful to us.
Okay.
But wait a minute, what did Roger do here? Oh, great.
Max, if this set replace packlet is being built every time, that includes, I'm just looking at it, I realize that includes compiling C code, doesn't it?
Well, I know, that's why it takes 6 seconds.
Okay, I guess 6 seconds isn't that bad. But
the point is, if it's going to be in function repository anyway. The chances are you'll have to keep build packlet somewhere, because I mean, in the case somebody
Right.
doesn't have a C compiler. So ideally, what I actually want to do is to have it automatically picked up as a build artifact in CI, in which case it will be automatic. But
Okay.
I'm not exactly sure how to do that. Well, actually, the main problem is that CI only builds it for Linux. Speaking of which, do you know how to? Is it even possible to compile Windows and Mac libraries from Linux?
Yes, I think so. I think we have a whole process for building these things as part of release engineering.
Are you talking about cross-compiling on Linux for Windows or on Windows for Linux?
On Linux, for Linux and Mac.
On Linux for Windows, I don't know of it being possible to compile on Linux for Windows, possibly for Mac, but because in release engineering compiles for Windows on Windows and for Linux on Linux.
Yeah, I think that's the only way we know to do it.
Okay, as far as I know, Docker images cannot run either Mac or Windows.
Yeah, well, you can run Docker images of Windows on Windows, but not on anything else, to my knowledge.
Okay, I see. Yes, it's going to be tricky to build the whole thing in the CI.
Well, if it's just what's the CI you're talking about? Some continuous integration thing?
Right, because the benefit of that is it automatically builds everything.
Well,
which
how is you
means,
implementing it?
well, I'm using a service called Circle CI right now, which, I mean, I only need to make a Docker image and a config file, and it does everything else. And I can make it use build artifact, meaning that you have a place to find the packlet in there. But it would only work on Linux.
Well, you could have release engineering build the packlet for you on all three platforms. That's relatively easy. That's what they do. And then, I mean, the place for storing build artifact packlets is the packlet repository, whether the internal one or the public one. I don't know if RE pushes that automatically from builds.
Okay, so all right. Well, let's see. So what have you guys figured out? Sorry, I'm just doing this. Okay. I'm trying to figure out whether I can run. That seemed unconvincing. What the hell? Oh my God. What? The resource object parallel?
Are you connected to the right cloud account?
I am not. Good call. Good call.
Thank you. Are those resource functions going to be required inside the jobs?
Maybe. Yes, some of them will be. Yes, some of them will
Okay.
be.
If they are, then they will need to be actual public resource.
Well, they can be. I think these files, this is public. So you can go there. It just is some complicated URL.
Okay, but why didn't it work while connected to another account?
Because
Well, you probably need to use that URL, otherwise it cannot resolve the name.
Oh, okay.
what the heck?
Which, by the way, I think you should be using the physics initialization file, because otherwise nobody else can use it.
Fair enough. Okay, well, this is much more broken than that because this is something. Oh, gosh. Well, the reason for not doing that is that then I have to replace those things when they become public resources. But okay, I think it's a fair point. Let's go ahead and resolve each of these as oh God, not this problem again. This thing froze that.
Yeah, it's that progress thing. I guess evaluate in place does not work well with that.
Okay, so here I can just do set replace there. Now I'm going to do this. And that should work with that. Now I just have to go and evaluate everything else here. No idea why that opened up down there. What is that doing? Why is that opening up down there? What I'm hoping I will have done is to set it up so that we can use parallel, so that we can deploy universes in parallel because we've got the use front end stuff in there.
Does that mean a front end is required? Because the Wolfram engine in the jobs does not have a front end.
Not for what you're doing.
Okay.
That's really boring. This was the latest collection we were looking at, Max, and what I really think we should look at is things with more than one rule.
Sure.
I'm trying to get an example so that I can go ahead and deploy, try running Suspicious that we're exactly 7 may be interesting again. By the way, the reason I can't put that out I'm going to go ahead and just try some. Did we do 3-2? No, we didn't do 3-2 goes to 5-2. I'm going to do a few 3-2 goes to 5-2 just to get something interesting that I can use for this test. I don't want to pollute the registry with garbage. You know what I'm saying? Any idea how big this number should be for 3-2 goes to 5-2?
Let's see. It's 9.
Okay. Maybe we could just do the next one of these. Where do we got to in that? We were just doing 3-2 goes to 4-2. The next one we have is 1-3 goes to 4-3. We should look at those, but okay, let's just, this is out of sequence. This is a weird process of universe hunting, Jesse, in case you're wondering. These things represent how large the rules are. And these are going, and if you want to admire the things we already know, just go to just go there. I'll send you that. You can admire some we already have. I'll just send you that chat.
Yeah, they look nice. Will you have them on t-shirts or something?
Yeah, that we've been thinking about the swag aspects of this project since the very beginning.
You know, there are print-on-demand t-shirt places. You could have like a button that lets anyone print their favorite universe on a t-shirt.
Yes. Yes, 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 absolutely. Absolutely. Yes. I mean, we probably should have that on every page of this repository. We should have print a t-shirt of this rule. All right, let's see what puppies there are here. Who looks interesting here? That guy is mostly interesting for me, exotic looking. That one looks interesting. That one looks interesting, even though it does look like one, some kind of spaceship lander. Do you think that thing with a bunch of hair on it looks interesting? I'm not sure. I'm going to add that one just for good measure. All right. Now, what I'm trying to do, let's see, universe registry, interesting rules. There were 3.
So is this status field that here says not our universe, is that a Boolean? Are they going to be either not our universe or our universe?
No, because most of the time we're not going to be able to tell. And that field is currently completely fake.
Okay.
Okay, hold on. Let me just try this here. Processing 02. Now, what I'm trying to do is a test deployment. Why the hell is Publish Universe blue? Oh, because we didn't evaluate this. This is so annoying having to go through and do these explicitly. Okay. All right. Parallel map monitored. Publish universe. And I think I just map that over this. And let's see what happens. Because I inserted a use front end thing in there. See what happens here. This will be very useful if it works properly because it will allow us to deploy much more quickly. So this is trying to build those pages that you saw on the previous thing. Why is it still saying starting parallel map? Oh dear, what is it doing? Why would it, what does it mean when it says starting parallel map, Max?
It means none of the cases have returned anything yet. In other words, it's still running the first 12.
Well, I would expect, I don't think any will return. I think they'll all take about the same time to return.
Well, in this case, it will immediately go to result from this.
Yeah, I understand. That's not very good messaging for starting parallel map. I think it should say something different.
Yes, I know, but it's not an industrial function. So I did not, I mean, I never tried to make it understandable by other people.
It's a pity that this isn't working here. The big mystery is why meta information is being lost in, oh gosh, what is this doing? And I can't even tell. It's very hard for me to tell whether it's running anything interesting. I don't know. I guess I could run another piece of code to find out what the universe number will be for this. So how would you package? Well, okay. So, okay, the next one that was in sequence for what we were doing here would be, we just did 2, 3, no, we did 3, 2 to 4, 2, right? So the next one in sequence is 1, 3 to 4, 3, right?
Yes.
And the next one after that is 2, 3 to 3, 3, which I think will be an interesting one. How much difference do you think it's going to make that we don't have interesting initial conditions here? By the way, if you can work out what the 15 should be, that would be helpful. This will be fertile. 1, 3 to 4, 3 will be very fertile. So this means, Jesse, for your purposes.
It's 15 minus 3 and minus 1.
That would be 11.
So 11.
You should tell me how you're working that out.
Well, it's a total number which is in that list minus n minus, well, let's see. Okay, if we have multiple edges, there has to be at least one shared vertex between them. So we have 2, then we subtract 1 from 15. If we have 3, subtract 2, and so on. And there's also shared vertex between left and right hand side. In this case, there's 3 on the right, 0 on the left, and 1 shared.
This is profoundly not working. I mean, I think it's jammed. Damn. Do you think we can interrupt it? Let's hope we can. Bet we can't. Oh, we can. All right, let's try the same thing with ordinary map. How would I do that? Echo at star, right? That would work. Yes, no?
Yes, that should.
So.
Okay, so then the question is, why would parallel map not work? If this does work, why is parallel map not working? Because I did a use front end there. By the way, can you work out the 2333 case, what the maximum number is there?
Yeah. $11.
Right, I think you should give me the formula for.
Well, I just told you the formula.
Well, I know it. Let's write it down in terms of, let's just make a piece of code that does it. Oh, look at that guy.
Well,
that has a very insect-like look. I mean, that's kind of like a. Look at that rule. Look at that rule. Look at that rule. It's very linear.
Well, at least the right hand side is linear. Left hand side is hard to tell. I have good collection of data now in there.
On which?
In this notebook.
Which notebook?
Oh, the one on the bottom.
Yeah. It's really pretty good. I mean, there's more that we need to do. I was just looking at some graph theoretic properties, and do you know what the centrality? What is it called?
Well,
Centrality
I
versus-
heard of it. I don't completely understand it.
because it's very Gaussian for the thing we were looking at before. And I want to understand, in making a mean field theory of these things, I think we're going to have to use random graph theory of some kind. Because the question is, if let's say you had a random graph, then the question is, does it have, in a random graph, there will be a certain number of updates. By the way, do we know how many updates per, we have the list of how many updates happen per whatever it is, we have the states
Generation.
list. What's that?
The generation.
Yes. Do we have that list? Okay, look at that guy.
Well, not really, but it's, let's see.
Don't we have some kind of events list thing?
No, we don't. I mean, pretty easy to get from eternal object, but we don't have a function for it. I mean, property.
An accessor.
Yeah.
So what would it be? What would the thing be? It's don't we have an events list from the internal function?
No. But it literally stores events, creator and destroyer events for each expression.
Okay. These really are very pretty. Look at that guy. Look at that. How bizarrely it builds itself. Okay, I'm going to predict it's. Oh, look at that thing. Look at this thing. It's crazy. These are really wild animals.
Yeah.
Such a bizarre business. Yeah, we need to, by the way, the one other thing, this thing here, we really should have some heuristic that makes that smaller.
Well, it's not a heuristic, it's a minimum plot range.
Okay,
Which
right.
we could have.
Why don't we have it? And make that thing like.
I mean, I'm not entirely sure it's a good idea.
Well, I think
you see, I don't want to make it inconsistent. Now it's pretty clear what it's going to do. If we have all kinds of special cases, and
it just looks very
who
ugly.
knows what it's going to do.
It looks very ugly.
Why?
It just looks very ugly because it's very big compared to the other things we have here. It will look a lot better.
In that case, we need to set consistent plot range for all of them, which is a completely different issue.
No, we don't. It's just that this one is visually ugly because it's so big. That's it. It's the only reason.
The second one is much larger than the last one as well.
It doesn't matter. That's okay. It's just this particular one is really ugly.
Why?
It's purely aesthetic. I don't know, because that's the first thing you see on the page, and it's the least interesting thing on the whole page. If that self loop was that size, it would be fine. Look. See, doesn't that look a lot better?
Well, maybe because they're consistent, I agree, but
they're not consistent.
Yeah,
it doesn't matter that they're not consistent. The things are hypergraphs that have no consistency whatsoever. It's just a question that just looks better. It doesn't distract one with trying to wonder why that thing is huge. Otherwise, I'll have to have code here that specially goes in and sets the image size for the first element, which is really annoying. And it'd be really good to avoid that by just having the hypergraph thing not plot that,
Well, what if you want the opposite? You want the plot range exactly be the same as graphic bounds. That's going to be very hard to get.
What? No, we don't want to do that. All we want to do is look, if all we did was to make the image size smaller, in this case, we'd be fine. We just need something to deal with this case. It's a really, I mean, you can put some option to hypergraph plot to say automatic image size or something to do that, deal with that case. It's just a silly case. Let's run this guy. This is running fairly slowly.
Well, we have an option which is off by default. I don't see any harm in that.
Okay. By the way, we need to figure out a name for this hypergraph plot if that name has been claimed by something else, whether we call it ordered hypergraph plot or whether we call it something different. Because
Isn't the other one just unordered hypergraphs? Maybe we should call that one unordered hypergraph plot.
Why don't you look it up? I don't know. I don't remember.
Let's see.
This is running slowly. These things are doing something very elaborate. Oh, come on. It's stuck at 0.937. Why do you think it will ever get stuck? Is there some other pathology we haven't thought of yet?
Well, it means one of them is hard to calculate.
What's that?
It means one of them is hard to calculate.
I get that. I understand that point. But can you see why? I mean, in other words, I would have thought
not
that
if I look at it, but there can be any number of reasons. I mean, your limit for your max vertex degree is too large in the sense that there are definitely cases in which it's not sufficient.
Okay.
Even though it might be rare.
By the way, the reporting here, there's probably a straggler there, and that's why that's reporting. Wow, look at that. Wow, there was nothing interesting there. Does that surprise you? It surprises me a little bit.
No, there's only one on the left-hand side.
No, but there's 1-3 loop. We've had interesting things. I see. We didn't have anything interesting in the case of, but we did with a. Didn't we get things with? Let me just look here.
Well, that's somewhat interesting.
What's somewhat interesting?
Not really interesting because they're all nested. But in terms of heuristics, yeah. I don't know.
Oh God, they all disconnected. That guy is fun. That guy is definitely fun. He's growing fast, but he's definitely fun. Better run a few more of these. So what makes them disconnect like that? And is that something about the rule that's pathological that's making them disconnect?
Well, what constraints do we have on rule connectedness?
I think it's the separate connectedness of the hypergraphs for the left-hand side and right-hand side.
Well, for one thing, if left-hand side is disconnected from the right-hand side, then they will always be disconnected. But I don't think it's happening here, at least not in all cases here, because they're too large. So the next case is that some of the vertices on the left do not appear on the right, which means, well,
yeah, but does that mean it necessarily disconnects, or does that mean it can disconnect?
No, not necessarily. But there have to be other edges that connected these different parts of the left-hand side for it to stay connected. As existing hypergraph plot is only for unordered hypergraphs.
Oh,
Actually, there are two of them. There's hypergraph plot and there's a simple hypergraph plot.
no, that was the original one.
I'm not sure what is simple about it, but wow.
Well, so they should change the existing one.
Do you really
They should
think
ch-
this approach is going to scale?
Not
I mean, many
very,
will remain
you know,
many of them.
it's not great. It's not great. I mean, I think what will happen is the low-hanging fruit will have been picked and people will stop re-implementing low-hanging fruit. That's what I think. I mean, I think that, and then I think maybe people will,
Maybe.
I mean, I think it's a little bit of a mess, but I don't know how. I mean, well, it's kind of a nice one. I don't know what it's going to do. Is that fixed? Has that died out?
Apparently. Can you just do evolution object or let's see generations of them? Oh, apparently they're different. So I cannot see it at all.
What?
I cannot see from this picture that they're different. But apparently they are.
Yes. Oh, it's doing all kinds of little detailed things.
Is it?
Think so.
Can you see any difference at all?
Yes.
Where?
Well, no.
Can you run the same function without final state and see what it does?
I did. It's down here.
No, that's Wolfram model, not Wolfram model test.
Wolfram model test only generates a final state. It's limited. Oh. You know what the thing is? This thing has limited against something else, right? This Wolfram model test has all the limiters in it.
Oh, I
Has
see.
all the vertex limiters and things like that in it. So really what we want to do here, hold on one second. Let me just store this guy. Okay, so let's take a look at this one. It's a hypergraph, isn't it? Is it going to take forever to render 87,000 node hypergraph?
Probably. Well, it takes 5 times longer than ordinary graph plot.
Oh, look at that. Nice looking creature. I'll be happy in an ocean. Isn't that a nice looking creature?
So far you classify them either in the ocean or insects. Or how do you distinguish between the two?
Well, I think the insects tend to be, the ocean ones tend to be more symmetrical. The insects have legs that they land on, you know? Okay, I want to understand what makes these things become disconnected on the right. We should understand that.
Well, it's just partially connected to begin with, and then the left-hand side has nodes that do not appear on the right-hand side. Then there's a good chance that you're disconnected. So that seems a big mystery to me, but we can look specifically to exactly understand it.
Look, what is that if it's not an insect form? I think that one might be interesting. I don't know whether we could try running it a bit longer, but or we can just deploy it as assume it's interesting. Boy, these are getting kind of long. There's almost a whole line long. Is that guy? I mean, that guy is amusing, but I don't think he's interesting.
By the way, should we include the result of these filters into the repository?
All of the ones that I'm putting in there are maybe interestings, pretty much. I agree that we should run it.
Sure about it.
No, I'm not sure, but we can easily run it. I mean, I also think that these are moving targets, these filters.
Oh, definitely. But the metadata presumably always is going to be.
Right, but the issue is, I mean, one thing I want to look for is manifold ones, and I'm afraid we may have missed some manifold ones because they're exponential growth guys. And we need another test for manifoldism.
Well, the colored ones also have exponential growth, as far as I remember.
Which ones?
The colored networks.
Sure they do. I know they do. So I mean, my point is that there may be some nice manifolds that exist even in simpler cases, and we really should go check for those. And those, there's several interesting ones here. See, it's very hard to tell what these guys are going to do. It's very hard to tell. I don't know, we can generate like one of these here, like that last one. I mean, that was an 18-step creature, so we can go 22 steps, for example. It's still tiny. Look at how small that events count is. Are these ordinary graphs? No, they're hypergraphs. I think we've got to go back and look for ones for manifolds based on exponentials. Why is this taking forever? It's only got 1,800 nodes. See, that's kind of interesting, I think. I think that's going to do some interesting, I think it's going to have an interesting limiting behavior. I think if we look at the causal graph of that thing, what does this mean? That causal graph, yeah, that looks pretty exponential there. All right, we got two things. We could either look at a couple of, let's look at a couple of things with two rules, and then let's look at Rob's thing. So what would be the minimum case of two rules that won't be obviously boring?
Well, I mean, at least one of them should have two edges on the left-hand side, but apart from that, I don't really know.
Okay, but for example, do we think that there'll be ones, just a minute. So, I mean, do you think that we should have, well, okay, so we might have 2, 2 goes to, let's say, 4, 2. And how many symbols should that have? because the way this works is it has a list here of the thing with its symbol count. See what I'm saying?
8, I think. 8 on the left.
Okay, so now here it should be there's no point in having a ternary edge, right? We only can have binary edges here. Do you agree? Because we've either got a ternary hypergraph.
Well, we could have one rule input binary and output ternary, and the other one do vice versa.
Okay, fair enough.
But if one is purely binary, then, well, let's see. Actually, I'm wondering if one is purely binary and the other one is purely ternary, that means they're completely
separate.
Completely separate. Yeah. So there's no point.
Well, there might be an interesting structure, but I think the idea of a ternary on left-hand side binary goes to ternary. Okay, let's take a look.
I'm saying if there is binary, one rule is completely binary, the other rule is completely ternary, then they're completely decoupled.
Yeah, I agree. But can't they affect? Okay, now the question for some of these is, did they really use the fact that they are? See, these do not look any different than the things we've seen before. They really don't look any different.
Well, in order for that to happen, the growth should be non-trivial. Meaning that if it can match every single place, then it's not going to use a second rule. But we can't really tell right now.
Yeah, we need a way to be able to tell whether it's using the second rule.
I know.
Let's see. And a naive thing. Okay, so let's take a look. Let's try your idea of, let's say, 2, 2 goes to 3, 3. And 3, 1 goes to, let's say, 1, 2. Okay? You tell me the right-hand sides, I mean the symbol counts.
4, 6, 6 on the left-hand side. I mean, the first rule is 6. 3, 1. Where did 1 come from?
Oh, I'm sorry. I meant 1. I meant 1, 3.
Okay.
Sorry, you said 6 for that one.
Oh, wait a second. No, I'm completely it wrong. Let's see. So on the left-hand side is 4 total, but 1 is used to connect them, so that's 3. On the right-hand side is 9 total, but 2 are used to connect them, so that's 7. So that's 10 minus 1, should be 9.
Okay.
And I probably computed the previous one correctly as well.
Okay, can we get a formula for this?
Yes.
Okay, so what about this one? You think that's roughly right? When in doubt, just run it.
It should be 4.
Boring. You think, oh, that should be 4, you think? Well, let's run this one.
Yeah.
Do another one. These are very dull. Just balloons and worms. All right. But on the other hand, they clearly have growth, so they're clearly using both those rules, right?
Yeah.
Okay, so let's try another case. Oh, actually, we better try your thing with the 4 there. Okay, what would you like to try next? Then I've got another idea. What should we try next for the 2 rule case? Should we try 2 goes to, let's say, I mean, anything that grows here, we could go 2 goes to 2 3, right?
So actually, if you have the first rule that decays and the second one that grows, then every case that grows will probably will be using both rules.
What should be the number here? 2 goes to 2 3.
But
By the way, if everything decays, we're never going to get anything from the simple initial condition.
yeah, we need to use right-hand side for the initial condition. I mean, not, we need to use second rule for the initial condition.
Yeah. Let's try running this again. Well, let's try a different thing here. Let's try something much more complicated. Let's try something like 2 goes to 4 3. 2 3 goes to 2 2. If you can give me some sizes there, that would be helpful. What should that be? Can you tell me what the symbol counts should be?
I think 11 here.
Okay.
Seven.
Boy, this is taking its time. Just a second, I'll be right back. Oh boy, it's still not finished. Wonder what these will be like. We did 2-2 goes to 4-3, didn't we? I mean, the experience with most other systems is once you've got some threshold of complexity, wow. That's boring. Oh God, it's just worms. Well, it went to a lot of effort to make each worm. I mean, let's take a look at one of these worms. Why the heck didn't it recognize that as trivial? I think that's a totally trivial worm. You know what? I should put a periodicity detector for the difference patterns. Go back and do that. Right. Any other thoughts about 2 rule 1s? I'm going to try a purely 2-oriented 2 rule 1.
Sure. So my guess is the larger pattern sounds left-hand side of the rule, the more likely it's when you use both of them.
What? The larger the pattern, what?
On the rule inputs.
Oh, we
Because it
could
will be
try.
less likely to match the first rule.
Yes. All right, let's try.
Maybe you can try 5 to 7 to say twice.
Let's try 4 to 5 2. And you're going to give me. Why is that
I
interesting?
put a function into chat for computing the things. Okay, I cannot guarantee it's very reliable. But it's better than me.
What do I call to get it? What am I looking at?
Well, max connected atoms on of anything. Either one rule, multiple rules, or just a single signature. Well, you need to put those in. You probably need to put those in a list.
You don't have to. I could see you have a pattern for that case.
Each signature. No, because each part might have multiple signatures, so it should be listed on each side.
Okay.
Okay, I'm curious if it works anyway, but maybe it just works. Actually, it is just works. Okay, never mind.
This is not promising. It's not returning anything here.
It will obviously be slow compared to others. Okay.
Okay. This is one we want to run on AWS.
Okay, are you sure they're connected?
Well, it's running this connection checking code.
Okay. Well, I guess they're just large patterns then.
Let's kill this and let's just run a small number.
Or they're just all still zeros. It's also possible.
What?
I mean, either it just takes a while to merge these patterns, or it's just large vertex degrees. But obviously, the larger the number of rule inputs, the smaller vertex degrees it can tolerate.
We need to kill this, unfortunately.
Yeah.
Unfortunately,
Otherwise, yeah.
that's not working. Okay, let's consider Rob's
You
thing.
might need to try to kill it multiple times, because the first time you try to kill it, it will just return the object and it will keep running.
I know. You think if I kill it the number of times that I have processes, it will make a difference?
Yeah. So you probably need to. Well, I actually don't know what happens if you kill.
No, it's just killing the parent process.
Yes, but it would go in the parallel kernel and try to kill it there, and it wouldn't actually do it because it would. Yeah, I actually don't know how that works. Maybe good thing to test actually.
Okay, so this is Rob's function. I'm going to make a function repository entry for this.
Can we run it first and make sure it works? Because it didn't work for me last time, although I was not running the latest build.
What the hell?
Okay, that's the same problem that I was getting.
Let's try running to the prototype build. Oh, gosh. And minimize. Well, he says bug fix on the next build, so let's just see what happens if we try this. Without that S rules line. Oh, come on. What the hell is it saying here? Why isn't that a valid variable?
Maybe it's not x29 that's the problem, but that it's in vectors CR. Maybe it doesn't recognize this, the region.
Why did Rob send us code that doesn't work?
Well, I mean, I would assume there was some regression in the build since he ran it.
What the heck is going on there?
Clearly that's the part that doesn't work.
What?
Is it supposed to work? I mean, did it work before?
I've never seen this particular thing work. look at the only possible way. Great. Vectors doesn't appear in the documentation for minimize. Well, I don't think we can do much about this, but you're proposing that we weight the distances based on their time to last previous neighbor in the causal graph.
Yes. Well, let's think what's the correct way to actually define the distance.
That's a
so
light
if
signal.
what is that?
I mean, that's like a light signal. I mean,
yes, but if you want to send and then receive a signal, we need to have some kind of persistence of objects, which we don't have right now.
right. No, the universe is
So
expanded between
alternatively,
those times.
we can send light from both of them and see whether the light meets, or alternatively send the light into the past, which is
Which is what we're talking
common
about.
ancestor we're going to do.
Yeah, right. So finding a common ancestor and finding the, finding a distance based on time to common ancestor seems reasonable to me. Now, what we could do, we could make a weighted graph from all pairs of nodes, finding their common ancestor,
Yes.
right?
Yeah. Well, I mean, the problem is that finding ancestor is not the present distance. Because
I understand.
so finding an ancestor will give us a small distance, and finding, the future shared event is going to give us a much larger distance if it grows.
No, but still, it gives us some indication of the distance. To find the common ancestor gives us some indication of distance.
Well, definitely.
But these are distances between
But the scale will
events.
probably be too small.
Okay, but look, this is distances between events, right?
Yeah. So for expressions, you would just took the creator event.
We could do that, but we
In
could
which
just
case,
look
the
at
distance
distances
will be
between.
1.
Right. So why don't we just look at distances between events? So why don't we take a causal graph, right? Like the causal graph of the of our favorite rule. So let's call this causal distance.
Well, if you want to lay out the causal graph, then it's probably more tricky than this.
Okay, let's get a causal graph here.
Actually, I think it's better to try lay out space slice graph first, because I think it's easier.
No, but I'm trying to get the events.
Yes, so you just use creator events.
Okay, well, hold on. Let's just get something specific here. And
you will probably have to use internal evolution object structure.
Okay, so here's an object.
Yeah.
Now what?
Can you do part one of this object so I can explain you what's in it? Okay, can you do the smaller one? Let's say 2 generations. Okay, so it stores each expression for all across all generations. The atom lists are expressions themselves. Then generations, well, obviously generation of each of them. And then it also tells you what each event created them and which event destroyed them. So, well, that's all. Pretty simple, actually.
So for each atom, by the way, why don't we give a property that just returns all this stuff?
Yeah, I think what do you mean all this stuff?
Well, just these things here. Creator, destroyer,
It's
generation.
an association.
Yeah.
I mean, I would imagine you just need multiple properties, which would just be create event for a specific expression and so on.
No, but we want to return all of them.
Well, if you don't give any argument to it, it will return all of them in the correct order.
What do you mean?
But, well, so if you ask create an event, it will do the same thing that word.grid does for graph. It will just return the list of them.
So wait a minute. So you're telling me if I do this and I say creator.
No, it doesn't work yet. I'm talking about potential design for it.
So these are basically edges here. Isn't that correct?
Yeah.
So it seems to me that a useful thing to have would be, I mean, something like edge histories. And that would look like for every edge here, it's the creator, the destroyer, and what generation it was produced at. I don't know whether that's reasonable. I don't know if that's useful. I think that the let me look at what happens here.
These are kind of separate. It's I think very reasonable to have creator and destroyer events list, but then generation I think should be a separate property.
Okay, well hold on a second. So this
a
is
different thing.
this list of edges. I mean, don't we have a thing which is like an all edges list or something?
Not across all generations.
Okay. Well, so we obviously
Maybe you
have...
should do it per generation. Well, actually no, because if even in other words, if the expression generation is n, it doesn't mean it cannot appear in generation n+1.
Right. Exactly. By the way, I really want to try random updates because I really want to include in our reports on each universe, it's random update, some sample random updates.
Yeah.
Okay, so sorry, what was I looking for? I was looking for the documentation. Actually, what I want is not this, but it doesn't really matter. I can look for this one. Okay, events list, the list of all events during the evolution. Does that not exist? Did we not, in
No,
fact?
it does not.
What did we imagine that would be?
Well, it will have specification for an event, which is the rule index, input and output.
But which is consistent with what we're using in multi-way system, right?
No, it
It's
cannot
got
be
to be.
because in multi-way system we are saying too much. We include the entire state in the multi-way system.
Okay. We need to add this to the to-do list.
I should pay attention to this to-do list. Is it sorted by priority by any chance?
Not really.
Okay.
I mean, we can sort it a bit more by priority, okay? Okay, so this, hold on a second. Add but let's just figure out the low-hanging fruit here, because this is well, the events count you can trivially compute, right? Events count is just equal to the number of these, isn't it? Number of creator events.
What do you mean?
The total number of events.
Well, we already have that.
What is
we
it?
have events count. We don't have events list.
Okay, but so one thing we want is generation events count list. We can trivially get that from this thing here, right?
I think so, yeah.
So let's at least have that one. Generation events counts list. And do we have events count? If I look at
yes. I mean, let's at least. I mean, if you, I don't think it's gonna save me much time if we implement it now in here.
no, I understand that. But I'm just saying it will be useful to see. Well, I mean, let's just do it for this particular rule, just because I'm curious what it looks like, okay? So here,
Sure.
we can say, okay, so then this is by generation. What do I do here?
Well, we need to find the first instance of each number in generations. We need to get position of the first.
No, we just need to get position of everyone. Look, we need to get position. Let's just look at the next level. What is the correspondence?
Okay, take differences of generations and then position of one in them.
Differences of generations here.
Difference of generations list.
Okay. Why? No. What do you mean? Differences of that?
Yes, and then take
oh,
position one.
And then take the differences of that.
No, position of ones.
I know. And then we take the differences of that, and that tells us how many events there were for each generation.
No, it doesn't.
Why not?
It tells us how many expressions are in each generation. So now you need to take creator events on these positions plus one. So add one to each of these positions and take creator events.
Okay, hold on. Position, that, comma one. Okay, so wait a minute. What we need to do is...
No, it's all
Oh,
one.
hold on a second. GECL of WM of evolution object. Hold on, equals EE sub one. Okay, then that what we want to do is that thing you're saying generations, right?
Yes.
Is that a symbol?
Yes.
Okay. Okay, so position differences. Add one to that. Okay, now what? Now index into creator events with that. Is that correct?
Yeah. I have to think about this plus one, but well, let's try it. Oh, I see. There's generation events count list. Okay.
So that purports to be the number of...
Okay, we need differences of that.
Differences of what?
Of this, because it's event by that generation. Or something like that.
No. Look at all these creator events. There's tons of creator events that are in this generation.
No, it's one.
Why?
It's one event creates 5 expressions. So it appears 5 times.
Oh, I see. I see. Yeah, and the differences will actually be subtract the, okay. All right, so now,
Okay, so that's probably generally correct up to that plus one maybe.
haven't we seen that before? Isn't that basically the sizes?
Yeah, the other sizes because, well, no, they're not the sizes.
Well, here, let's just go states list. What size would we like here? Is this the number of nodes or the number of
Expressions.
Okay, so is that what I'm computing with length?
Yeah, number of expressions.
I'm sorry?
Number of edges.
Okay. I think I'm noticing something here. Do you notice something there? It's the same.
Okay.
Differences of sizes
Well, that's
over
a good
2.
sign.
Why is that a good sign? Why is that right? I mean, why is that the correct thing? That the difference in sizes.
Well, it creates two expressions at each step. I mean, deletes 3 and adds 5, which means difference is 2.
Right.
So apparently it never skips them,
Never skips what?
expressions, in the sense that there are no expressions that are not matched. Actually, wait, that's not important. Okay, that's not important. Yes, it will always be like this. Yeah, never mind. It's correct.
Well, so wait a minute. So is this obvious? Is this the case that the generation events counts list is just something that is directly dependent on the sizes?
For single rule, I think so. Multiple rules, of course not.
All right, well, let's pick one of our multiple rules and see what it does. Which one would you like? Let's take that little creature there. Well, that's a little different, I think. Oh, no, it isn't. It's identical. So probably one rule doesn't get used there.
Okay, which, let's see. Can you show the rules again? Wait, what? Oh, I see. It's not a signature. Well, of course it's not. Why would it be used? They have the same left-hand side.
Yeah. All right, let's try some of these others. Okay, let's look at this. 1, 2, 2, 3, 1, 2, 2, 1. Okay, so those are not the same left-hand side, for example.
Okay. Actually, the first one in that case is more general than the second one, so it will still not use it.
Okay, so hold on. Let's do the following.
The second rule might be fine though. Yeah, I think only the second rule. I mean, the second pair of rules.
Okay, well, hold on. GCLO. They're all identical. Those are all identical.
Okay. I guess it doesn't use the second one.
Well, let's try for a bigger class here. Do you think it ever uses the second rule? Let's try a different set of these.
Well, of course it does. You can run the unit tests if you want. Definitely
No,
does
but I
run
mean,
the second rule sometimes.
okay, so what class should we look at? Should we look at 2.2 goes to, should we look at this one or should we look at another one? Let's look at one that's that elaborate. Let's look at this family, 2242, 2212, okay?
Let's look at the larger one,
I want to try
like
looking at this.
4-2 at least.
Let's try looking at this one. I just want to see whether this one ever works. Okay, so this one, so what we'll do here is,
I mean, it's pretty unlikely it will work. There are not a lot of ways to connect two edges.
okay, well, all right, fine.
I mean, it could work if there are self loops involved and so on, but it's unlikely.
I got to tell how many symbols. How many symbols should we be using? No. What did I do wrong here? What the hell is it doing with recursion depth here? Who's clicking are we hearing? Is that Jesse still?
It's me.
Ah. What is wrong with this? Why is this generating?
Well, I think it gives some internal function repository symbols out.
Oh, for God's sake. It would be faster if you just implemented this thing.
Which thing?
The thing that just tells us how many events per, well, which rule, whether, question about whether the second rule ever gets used.
Well, I know we need it.
Yeah. Like being able to tell which rule is used.
Yeah.
All right, well, oops, what just happened there? I think this is crazy because I should have put limiters on all of that stuff. Well, okay, is Jesse still with us? And did we?
I'm here.
You sound very subdued. I'm sorry. I mean, were you doing something useful here, or I'm sorry. I should have.
It's fine. It's fine. I'm working on building the kernel, the 12.1 kernel for Docker. For Docker.
Excellent. Well,
By the way, where do we put them? In the Docker containers.
Where did I put them? Amazon Elastic Container Repository. They have their own Docker repository service thing.
Okay, because I probably would want to use it as well, especially if we keep it updated there.
I'm not sure how much I'll be able to keep it updated, but I'll see. But yeah, I can help you get set up to use it if you like.
Yeah.
this is pathetic. Look at these things. They just give zeros there. Yeah. Okay. So these random examples, the second rule is never used. By the way, I mean, so in a causal graph, so let's imagine here that we make the causal graph. Okay, great. Now we are asking the question for every pair, I don't know how big this thing is. That's a bit big. Let's look at a smaller one first. Okay, so that one. So what we want to know is for every pair of nodes here, what is their relative distance, right? So I think isn't that a distance matrix?
No, it's not that sort of distance.
Why not?
We need to find a common ancestor.
But this is a directed graph. Oh, I see what you're saying. Well, let's look at the distance matrix of this graph anyway, just to see.
Well, the distance should be infinity if they are space like, which is only case if you care about distance.
Hold on. So this is Can't we get the distance matrix for a graph?
It's graph distance matrix. Graph distance matrix. By the way, do you know that in the options there is fuzzy autocomplete, in which case you can type, the last part of something.
I'm aware it's not ready for prime time. We're working on it. That's kind of amusing, by the way. I wonder what that looks like for slightly bigger. Isn't that interesting? I mean, that's kind of a light cone.
I think I understand it.
Well, so it starts from the node up there, right?
Yeah. Oh, that's why it's connected to everything.
Yes. And there are a bunch of nodes here that are space-like separated. I think this is quite an interesting thing because these are the nodes. Do you see what I'm saying? These are the ones outside the light cone. These are the ones that are not connected. Right?
What do you mean? It only connects lower index to the larger index. That's why the lower diagonal is
I see. But okay, fair enough. But these ones here, right, could be connected but aren't.
Sure.
Right? So
well, they are probably at the end of the trees, so they're not connected to a lot of things. Yeah, they're just near the end of the tree. So they're only connected to one vertex or two.
yeah, I understand, but those are things close to the edge of the light cone, right?
Yeah. Well, close to the final state. It's not. So there is the edge of the light cone.
Isn't there a way? I mean, in a layered graph plot, which is isn't there a way of figuring out how many steps from the root node each node is, and sorting the nodes according to how far from the root node they are? Right, and if you do that, then anything that's
what are you trying to do? I saw you wanted to figure out the distance matrix.
I do, but first of all, I'm doing something different, right? I'm trying to get a qualitative picture of the light cone.
Okay. Right.
So I'm trying to get some sense of I mean, this is like propagation of information. Look. Okay, is that a light cone that we see before us? That says that one event, I mean, okay, how does that relate to?
I don't think the fact that it looks like a cone has anything to do with it being a light cone. especially since if you start with the first event, the light cone contains everything.
Okay. That's that line there.
Yeah.
I mean, this shows us that the first event this shows us kind of the flow of information. So it suggests that an event over here I mean, an event over here has, I have to go far back to get a common ancestor with this one. I think this shows something. What the hell does it show? Let's pick up a random other rule.
Well, it kind of shows a growth rate. The less dense these lines are, the faster it grows. Well, the less dense these lines are, the faster it grows. Not sure. Okay, yeah, that's pretty clear.
Explain this picture to me.
Well, it tells us from around 50 until 87, events are not connected to anything. And then events from 30 are connected to one thing, so they're one level up in the hierarchy, and so on.
You're looking at which thing here? You're looking at which?
Well, if you look at vertical lines, the number of diagonals, or, well, they're not diagonals, the number of things that intersect is a layer of this event from the bottom of the tree. So you can see events after 53 or so leaves. And 30 and above
okay, so that's not
level
completely
up and so on.
useless. So that's a kind of interesting. Okay, let's take an example and let's take another example. I don't know what each of these is, but let's take just another random example.
Yeah, I mean, I think it's useful to look at this we can see how random it is.
I think this is a pretty useful indicator of something.
Well, if nothing else, it's indicator of growth rate.
Why?
Well, the denser it is, the faster it grows. Because if
Fine, but that's
well,
boring. I mean, the point here is that what does this mean? This is something to do with I mean, we could probably color this by generation, couldn't we? Which event is associated with which generation?
yes, we can.
So that would then show us.
And all the generations can actually be computed for this.
Right. I mean, we could color the causal graph by generations as well.
Oh yeah, that's actually a very good idea.
Because that will show us, so those generations are, yeah, it's the causal graph for this particular choice of, right, it'll be in this layered graph. What's the relationship between the layered graph and the generations?
Well, if it's layered correctly, then each layer is a generation. But I don't, some probably isn't. Well, I mean, I don't know.
Why wouldn't it be?
I mean, maybe it is. Well, although, no, it definitely is not, because if you look at the bottommost layer, it has one very sticking out.
Okay, so why wouldn't this be layered correctly?
So it should layer by minimum distance from the root, I think.
And what else would layered graph plot be doing? Maybe we have to tell it the root.
Well, it clearly is not doing that. I think it's, well, I don't know.
Well, let's look it up. So we need to ask Charles what it's actually doing. Let's
The
ask.
documentation is very vague.
Right.
It doesn't
Does
say
this
at all what is.
lay out vertices based on their distance
Well, obviously it doesn't.
from the root node?
Well, obviously it doesn't.
How can we make it do this? So is it the case, can you give it those hints, those coordinate hints? Does that work in graph?
What coordinate hints?
The thing you were doing where you're setting the coordinates, the constraints for the coordinates.
Oh, well, I mean, I don't know. You can try. I didn't
No,
try
no, no,
this
no, no,
layered
no, no.
graph plot.
No. Yeah, are you giving only, can we give just a y coordinate and not an x coordinate? Can we fix the y coordinate but not the x coordinate? So what I'm
You mean
asking?
hypergraph plot?
No, I'm just graph plot.
Well, I know you can do it for spring electrical embedding.
Yes, okay.
I don't
So
know if it works with layered graph plot, but
no, I understand, but
you
it will
can
be
try it.
sufficient. Okay, listen. I'm asking if we want to get, okay, can we fix the y coordinate but not the x coordinate? Yes or no?
Yes.
Okay, all right, fine. So then in that case, what we should do is take this plot, right? This one
Yeah,
here.
I see what you're saying.
and we should compute for every node what its distance, where is the root node? Is it a numbered node that's the root node?
Well, technically there is no root node, but in this case it's going to be 1. Because the initial condition is
okay, so we haven't given an
simple.
unfortunately, an initial event, which is another thing that's on the to-do list, is to put in the initial event.
Right.
Okay, but can we assume that the low numbered event, I mean, is there a single initial event?
No, there isn't, but because our, well, in the cases we are looking at right now, it's going to be 1.
Okay, when is it going to be 1?
If there is only one match, or if there is only one event that directly uses initial condition.
Well, that's going to be the case for these minimal initial conditions, right?
Well, yeah, that's what I'm saying.
Okay, and it's numbered 1. Right?
Yeah.
So then for each of these, what we would do is we compute for each node the distance. So how do we compute, how do we put in the coordinates?
Well, it's you just put automatic instead of one of the
No,
numbers.
I understand, but how do we specify the coordinates? Is it vertex coordinates?
It's vertex coordinates, yeah.
Okay,
And
so
it
here.
now accepts list of rules.
Okay, so fine. So for each vertex here, so in CG, we have to know the, what is it, graph distance from, for every node, right? Graph distance
Right.
from, it's a table.
I'm not sure. No, it definitely should not be, because there's more efficient. I mean, it's linear time to compute distances to everything.
Okay. So you think it's graph distance matrix?
Not matrix. That will compute too much.
Okay, so what do you think we should do?
Well, we need to find a function that does it. Let's see. It's graph distance with 2 arguments. Yeah, this one.
Okay. All right, so then what we want to do is for each of those, do we give a list of rules here? So we're doing a map indexed over this, is that correct? We give a list of rules, is that right, for the coordinates?
Yes.
Is that right? Okay.
Yes.
Okay, so then here we say first of hash 2, arrow, automatic, comma minus hash 1, right?
Yeah, I think so.
Okay, so here we would be saying graph of CG, comma that, and that this is vertex coordinates, right? Is that correct?
Yeah.
And now we say graph layout. Do we have to say that explicitly? Yes.
Probably. Spring left. It's should be one level out. It's not in the map index.
Like this. Okay. That's very nice. That's very nice. So that will give us Okay, so let's write this then. What should we call this? Fully layered graph of graph G root.
Well, it's really layered by generation.
Okay, let's call it distance layered graph.
Okay, yeah, that's better.
I think that's it, isn't it?
Maybe root should be vertex least at position 1.
Okay, we'll worry about that in a minute. Okay, why are there events that are hanging down here?
Good question. Let's see.
This is relevant for multi-way systems as well, this distance layered graph.
Maybe the minimum distance is not what we want. Because suppose there is event, so we have, let's see. Right, suppose we have 3 events. So 2 depends on 1, and 3 depends on both 2 and 1. In that case, 3 would actually have generation 3, even though the distance is 1. So it's more tricky than this.
To show the generations, to show events by generation.
Yeah. Maybe it should be the maximum distance.
Well, maximum distance isn't computable this way, right? Because this is the distance. But since you know the generation of each event from the underlying structure, right? From this underlying structure.
Yeah, we can get it from there. That's simpler.
Okay, so how do we get that from there? Each event. These are events in order, right? So these are the generations of each event. So we just pick up that list.
Well, except these are for expressions. So you need to find position of the event first in the creator events list, and then pick generation for it.
Okay, so walk me through how to do that. Okay, so hold on a second. This is a useful thing anyway. We should have a distance layered graph. So if we were to put here a complete graph, right, and if we were to put here, for example, a k-ary tree, why didn't that work? Why didn't that work?
Maybe because k-ary tree is not a graph. Can you check the head of it?
Inspect its head. It's a
Ah,
graph.
okay. Oh, does it have the event one? Or vertex one, maybe. Oh, presumably it does. Because, yeah.
Yes, it does. 1. So let's take this and we say graph distance percent comma 1. Looks pretty civilized. What the hell is wrong here? Vertex coordinates, those look perfectly reasonable, right?
I think so.
Is there something that Spring Electrical Embedding is just unable to deal with there?
I don't see why.
What's another type of graph we could just play with?
Well, let's do just pass graph.
What's that?
What's the pass graph? What's
Pass graph?
simplicity?
What are you saying?
Pass graph of range. Well, okay, that's more complicated, but sure.
Cool. That's exactly what we'd
Works.
expect. Yeah. That's exactly what we'd expect.
Right.
So why doesn't this one work?
Can you disassemble this tree and then reassemble it again and see if it helps?
This thing here?
Yeah. Just get edge list of it and then make another graph from that edge list.
Okay, that's really confusing.
Well, so there is something going
Oh,
on.
it probably had
in
its vertex coordinates in there.
So,
This should
why?
have written them.
Yeah. Well, I mean, that we can check. What I worry about is that it has some kind of different internal structure which vertex coordinates don't work for.
Right, I'm asking Charles. But that's cool that, I mean, in the case of what?
Well, it's technically correct.
But what's your point? That it's kind of stupid because because this is the correct form.
Wait, what kind of tree is?
It's a binary tree.
What? It's binary. Okay, so it shouldn't intersect this much, but I guess it just can't find the global minimum very well.
Right, but I mean, this binary tree is arranged precisely in a distance layered graph.
Yeah. No, I mean, it is correct. It's
No, but
just
this should be
very
a
much
no-op.
local minimum.
It should be a no-op.
What do you mean?
This graph, the original graph, is already distance layered,
Yeah,
right?
right.
So the fact that it messes around is kind of stupid of it, right?
What do you mean? This is perfectly fine. It's,
No.
it's
I understand, but it
minimum.
didn't need to do anything. It was already distance layered.
Right, but
drawing
no,
of
it
the-
wasn't spring electrical embedded in distance layer.
No, I understand that. I understand that. All right, let's go back here to the question of, okay, so this is now, we want this to be generation layered. Graph, right? And so for that, we have to go all the way back up here and pick up the generations, right?
Right.
So how do we pick that up?
Well, we need to get position for each event and then take generation with that position.
Okay, but for each numbered event, so what we would do here is we would take this and we would say causal graph of that. And then we would say
Just as
edges.
well have a zeroth event as well once you own it.
Okay, so there's the causal graph. Is that really right? Oh, I might
Could
need
be
to,
right.
yeah, let's do this case. Okay, fine. Okay, now how do we annotate that causal graph? Where do we get, how do we get the generation for each event in that causal graph?
Well, first we need to take event positions. So we do position of creator events, well, position of every number in
let's
range.
get EO equals this. Okay, position. Isn't there a better way to do position of every number in a range? Isn't that just an ordering? What are we trying to do?
Not sure.
Position in EO.
I mean, we could do
One.
difference position of ones. That would also be, it would probably be faster.
Say it again.
We can do differences and then take positions of ones. That would probably be
Okay.
faster.
All right. Okay. So EO, which one? Creator events, right?
Yeah.
Okay. Differences. Position of ones. Flatten. Oh. Okay. Now what?
Let's see if it's correct. No, it's not correct. We need +1 to it.
Okay. And what does that give us?
That gives us, okay, then do generations of that list. that gave us the first positions for each event, except for 0.
Okay.
Yeah, that's all we want.
Okay.
This
So
is
now,
y coordinates.
now what we want here.
Well, range of event count goes to this threaded.
Yeah, I understand. We don't need the graph distance, we just need this. Layered causal graph of EO, which is a Wolfram model evolution object, goes to okay, so instead of graph distance here, we have this jazz here, correct? Is that right?
I think so.
Okay. Do you believe that?
Yeah.
This is looking interesting. Huh. This is looking very interesting. Okay, what's going on here? This is looking very cool. Let's jump. Well, that's pretty interesting, isn't it? I mean, that's a better representation of the causal graph.
Think so.
So, for example, for one of these other rules, let's take this guy here.
I think the y coordinates there is cosmological time.
It is. That's correct. It is. That's in this particular space, like is in this particular ordering, with this particular.
Well, if it's cause invariant, then it would just be, in this cosmological reference frame.
Yes.
If it's not cause invariant, then
it's in this particular
branch.
It's in this particular. These are space-like hypersurfaces. This is a sequence of space-like hypersurfaces.
Right.
Oh, look at that guy. So that guy has probably separated its, it's separated its life, its world into these two pieces, right? It's no longer communicating.
Apparently.
Okay, so this is a representation of communication. This is our light cone. This thing here is the light cone, and this is the space-time diagram of the light cone. With respect to this particular foliation of space-like hypersurfaces.
Right.
So let's pick another rule, this one here, for example. So this one, I expect it'll be a very tree-like thing because it won't communicate at all.
By the way, do you understand what it means that picking a reference frame is essentially equivalent to picking different multi-way branches?
Do I, what aspect of do I understand that? What?
Well, it looks like picking different order of events can either give us a different reference frame,
Yes.
or it can give us a different multi-way branch.
Those things are equivalent. That's the reason that causal invariance.
Right, but one of them is relativity, and the other one is quantum mechanics.
I know. This is a big deal that these things are related.
I know it's a big deal, but the question: do you understand what it means?
Well, I don't think it's quite, the quantum mechanics isn't quite that it's a single branch. I think the quantum mechanics is a slightly different story, but I think that they're close to, I mean, this is the first time that one's seen how relativity and quantum mechanics could get related like this. And particularly general relativity, it's particularly interesting there.
Right.
But, you know, the third leg in that animal, so to speak, is, and by the way, I don't like the fact that this thing didn't untangle itself.
Well, it's unavoidable. Spin electrical embedding. It cannot find global minimum every time. I mean, it happens with grids as well.
Yeah. Well, because it's a tree, you think. I mean, so let's say we go to 11 steps. But in fact, in actuality, if I went to fewer steps here, yeah, then it can find it. Let's just go to our gallery for a second.
Actually, I think it should do it by default.
Which?
When you ask for causal graph, it should use this layout by default.
Yes, I agree. I think this is a very nice layout. Although, well, I don't think it should be by default. I think we should have a thing called layered causal graph that is this. This should be layered causal graph. Because I think sometimes it'll be useful to see. Yeah, I think so. I think sometimes.
I mean, we can always convert it to normal spin electrical embedding, but the question is, I think this one is better default than just spin electrical embedding.
I think that we want a graph that is just a graph. I think this should be layered causal graph. I think it'll turn out to be important because I think that this, yeah. Okay, let's just look for a second at oh great.
I mean, they're both just graphs. Just one has automatic coordinates and this one doesn't.
Okay, pick a graph here. Which would you like to see? Should we look at one of these guys?
Sure, okay.
Actually, let's look at that one. Oh, for God's sake, why is this so damn slow? Well, that's interesting. We should probably rerun everything to generate these. Why is this slow? Let's take a look at some crazy guy like that. So this is probably going to be quite tree-like. Yeah, it is tree-like. I wish we could untangle these trees. We might need some special thing to untangle the trees. But we can tell, I mean, right, we can just test for that.
Well, if it's a tree, it's not very interesting. What we really need to untangle is if there's separate branches after some generation.
Right.
Which
okay,
I
which
think
one,
we can actually do.
Which one should we look at here? What is going on with the cloud?
We can try the one that has disconnected pieces.
Yeah, I just want to try this one first. Okay. It's a bit easier to understand than that. Interesting. I love the way that it forms these kind of ribbony things. What do you think those are? Those aren't particles, are they? I kind of wonder if these, if this thing is largely uniform, but there's some regions that are much more connected like that potentially interact with each other. And this is the space-time diagram, basically.
Yeah, this is a good point. I mean,
What would a particle look like? I mean, assuming that the nodes were roughly uniformly distributed in I mean, a particle is communication between is something that's somehow communicating. Now let's take a look at this one a bit further. See if we can go to 20 nodes.
well, can you make a particle and see what it does?
What do you mean, can I make a particle? How would I make a particle?
Well, you can make 1D particle.
Yes.
It's
Yes,
not
we should do that.
terribly interesting, but it's something.
No. But we could do that, right? I mean, we've probably got rules that naturally make them.
Well, I don't know about that. I mean, we can make one on the grid as well.
Okay. Well, but I mean, can we make them with these rules? Because that's what we need to run this whole technology.
Well, if you start from a grid initial conditions, then definitely. Yeah, why don't we put, well, okay, we need, okay, if we just put like single vortex edge particles on the grid, that's not going to be very interesting because the causal graph would just have two branches.
Look, this is the disconnected guy.
Is it? Wait, can you show the state itself? No, it's not disconnected yet, apparently.
Yes, it is.
Well, in that case, the only explanation is that it's not a good layout.
I agree.
It's entangled, whether it's.
But you know, we should be able to help the layout by actually computing some, you know, can the graph be separated?
Yeah. We can compute it, but I don't know how to specify it.
No, I understand. With respect,
I mean, we could try this initial coordinates thing, but it didn't work at all last time I tried it.
okay, well, we can try that. But let's just consider the particle question, then I got to go to sleep. Hey, are you around over the next few days?
Yeah.
Okay, well, so am I. Okay, what's really good about this is the same as a diagram in NKS, but this is now a vastly more automated way of making it. So in NKS, I show this, right? But I don't think this is the same. No, this has not been layered, but then I show, yeah, here, look, let me show you something. I show this, right? And that is the attempt to layer. That is a particular updating order. That's a layering with a particular updating order.
Okay.
I see. God, we got to be able to figure out a mean field theory of these things. Like, if the graph is dense and every place there's local rewriting, I think this will be a uniform picture. Right, assume you have a big, okay, assume, we got some weird echo. Are you still there, Max?
Yeah.
Okay, assume we have a very big initial condition, right? And we have a rewrite that isn't doing anything very exciting. It's just diddling around with stuff.
Okay.
But we start from one piece of that big initial condition. We'll still have a light cone like this, right? Because it'll gradually diffuse out to other parts of the initial condition. See what I'm saying?
Yeah.
Actually, that's it. Okay, just a minute. Big initial condition, a big random initial condition. Then, okay, then we look at the light cone from a given event. And then we ask the question, yeah, I mean, that's going to give us the particle story, because it's just like in Rule 30 or something. If you look at the difference pattern, if there's a particle, it'll propagate out. You'll see it propagating. If there isn't a particle, nothing much will happen. Yeah, I think that's a reasonable way to look at it. Okay, I need to go to sleep. But to be continued. Look, if you manage to get layered causal graph implemented, that would be super useful. Otherwise, I'll put this into our. I'm not going to do it tonight. I'm too tired. I'll put this into our thing so we can generate these in the reports, so we can look at these. I don't think that's completely useless. Nor do I think. I mean, I don't know what the difference between this layered graph plot and yeah, we need to understand these different kinds of plots. Yeah. And then we really need to understand, in this causal graph, if it's causal invariant, then the topology of the causal graph will be the same, but its generational layering might be different.
Yeah.
And it will be good to see that. It will be good to see that for a particular example. I think we also need these layered causal graphs for multi-way systems. Because they make sense there as well, don't they?
I think so. It makes sense if we do steps on merged version.
If what?
If we do steps on merged version.
Why do we want steps unmerged? We have a causal graph. Whatever happens,
Well, steps are merged. It can have loops in it, and then generations don't make sense anymore.
You're saying steps merged?
If steps are merged, it might have loops in it.
We need to understand that.
Well, it's not that hard to understand. If you have empty string goes to A, and then another rule A goes to empty string, that would create a loop.
No, I understand how there can be loops. I'm just not understanding the relationship between those loops and the loops here.
There are no loops here.
as a directed graph.
Yes, there are no loops here. The loops are not possible here, just by the way it's constructed.
I see. Your point about the unmerged is that, yeah. A single thread of evolution is an unmerged evolution.
Yeah.
Right. And the merging is just convenient for understanding the multi-way system.
Right. Well, merging in a sense gives us more information than we would otherwise have, because we can evolve system for n number of steps and get evolution for more than that.
Yeah, I understand, because something may repeat. I mean, it may be,
Yeah.
we may already have seen that. Right. I mean, in the, we imagine that the merging of a multi-way system is merely a mathematical convenience.
Maybe. I'm not completely sure about that. Because it's, if quantum mechanics had normal probability, then it would be obviously the case. But since it has amplitudes, it's tricky.
I don't think that's, I think that's going to come out more easily, right? Because
I mean, do
think,
you have any idea how can we get something like amplitudes?
no.
And that apparently has something to do with merging.
I think it could have something to do with merging. Yes. Because I think that
I mean, it's possible that amplitude is emergent effect of
exactly.
rule.
Yeah, exactly.
But it's also possible that we don't understand how to do merging correctly.
Look, the fact is, imagine that these clumps in the layered causal graph are particles.
Okay.
Then the issue is there's a certain amplitude. Let's say there's a certain amplitude for the particle to go one way or the other. And we can get those two things. Imagine we're not causal invariant. We can get those two things on two different branches of the multi-way system, right? So given each
Right.
branch of the multi-way system, we have a particular causal graph. So two different branches give two different things, okay?
Right.
Now, you might say, well, we just get probabilities. So when we combine,
If
you
you
know
don't
what?
combine them, we
You
get
know what?
probabilities.
What's that?
If you don't combine them, we
No,
have probabilities.
exactly. Because it's like one set of things happen, another set of things happen.
Yeah, but not amplitudes.
I understand. But so now let's consider the case where there is merging, right?
Merging in what way?
Merging of states. Where, in other words, where these different causal graphs, where we compute what happens, not by just adding up individual causal graphs, but by looking at some more complicated averaging that works through these merged causal graphs. right, that works through multi-way causal graphs. Right? Instead of just saying we got a bucket of causal graphs, bucket of you know, single evolution order causal graphs, right?
Right.
Then okay, then our alternative is we've got a multi-way causal graph which had merging in it. And now we're trying to deduce let's see, we're trying to get expectation values out of that. In the other case, we get expectation values by just saying how many times did this happen. By the time we've got merging, we've got to have weights. Right? By the time we've got merging, we've got all kinds of weightings. See what I'm saying?
Yes, some weights 1 over something because there are multiple cases.
Well, it's not 1 over. It's the multiple cases.
But it's 1 over. I mean, if we have two different two different branches converge to the same event, and we only count this event once, that means its weight of each of those branches is going to be 1 over 2.
Sure. But I'm not sure we do count it only once. I mean, that's the question. Is what the measure...
Well, if you don't count it, you will just get probabilities proportional to the number of branches, which doesn't seem to work.
No. Hold on a second. Hold on. I think what's going to happen is we start with that, but then we end up with... We start by saying we're just going to count branches, okay? But now we represent things in terms of these merged branches in the multi-way causal graph. Okay, and it is my suspicion.
What do you mean?
Well, instead of considering the individual branches, individual causal graphs, we consider this merged causal graph. Okay? The true answer is the individual causal graphs. Okay? I'm going to claim that there's going to be a calculational device that comes up about when we have these merged causal graphs that will be something like that taking two merged causal graphs. Okay, here's what I'm going to claim. Combining two merged causal graphs has a different calculus than combining unmerged things. And that calculus will end up being something more like amplitudes. Okay, because imagine you've got a merged causal graph. You can't just, you know, to combine.
I see what you're saying. Yeah, in that case, yeah, right.
Right, so combining two merged causal graphs, you have to do all kinds of, you know, you have to do sort of a path integrally like thing in order to get what the individual pieces would be.
Yeah, and the observers can, I guess, then only see the merged ones.
Yes, that's right.
That is very weird. Let's see. So then observers would exist on all instances of the merged branch at once.
Right, but to the observers, their view of the world is based on merged causal graphs because they exist on all branches. So to the observer thinking about merged causal graphs, the only way of working out the unmerged case is to essentially do path integrals. Because the states that they believe exist in the world are based on...
Path integrals already have weights in them, so...
What's that?
Path integrals operate on merged causal graphs already.
No, I know, but you have to back out the merging to find out the real probabilities. You have to back out the merging.
Yeah.
I think there's something to
Okay, that would make perfect sense if amplitudes were real numbers.
Yeah, but the fact that they're complex numbers is just, I suspect, they could be vectors as well. And in fact, the fact that they're vectors and, they could be some more complicated thing in some vector space, which in fact they are.
Well, I mean, of course they are, but let's see. Yeah, but I don't understand where would we get that from.
I'm not sure. But I think this idea...
Because, I mean, one would think that merged causal graph would just have counts in them.
Yeah, but there may be different parts of the merging. I mean, that is, you could have one piece that was merged, and then it's not really independent of the next piece, and so on. I think it'll be more complicated. But...
Well, yeah, because you're not doing the whole cosmology in the... Right.
But I mean, just to zoom out for a second, okay? So this idea that the observation of quantum mechanics comes because the observer's perception is based on merged causal graphs, and but yet reality, insofar as that's a meaningful concept, is unmerged. And so it requires a whole calculational apparatus to deduce the unmerged case from the perceived states from the observer. Yeah, I like that idea. I think that's an interesting idea. Look, I mean, we've got...
Actually, it seems to me it's not... In other words, just because it can be merged, it doesn't follow that observers have to live in the merged ones. It's actually a significant statement that observers live on merged.
It is, yes. It's an anti-many worlds idea. It's a plurality of worlds rather than... No, not a plurality.
Why?
What?
There can still be different branches which are completely separate. It just, when we happen to have the merging that can happen, observers exist on all of them. It doesn't mean observers can split.
Well, I think though, well, whatever. I think
it is completely separate things.
What's that? Okay, but look, the basic point is we've got several things going on. We've got relativity coming out from the need to have a single thread of time. We've got quantum mechanics from the fact that in a sense that single thread is actually potentially a multi-threaded thing. So in other words, we think as a single thread of time, but that single thread, if there's causal invariance, then fair enough. But if there isn't causal invariance, then necessarily the observer's sort of consciousness is multi-threaded. So that's that side of things. Now, the other side of things that I think we're going to be close to is local gauge invariance. Because I think that this, I mean, I don't really understand what local gauge invariance, I mean, you know, formally I understand what local gauge invariance is. But I mean, local gauge invariance lives on a base space. It has a fiber bundle. It is talking about the connections between fibers in the fiber bundle. And I kind of think, I mean, it just feels awfully closely related to what we have. I mean, what we have.
Okay, I don't really understand fiber bundles.
They're not very exciting. I mean, you just have, it's just saying that there's there's a piece of a gauge. There's a gauge element sitting at every element of the base space. So it's just saying, think about it like a, okay, but the issue is, how do you go from one, but these gauge elements are just sort of arbitrarily chosen. And the issue is, how do you define a connection that tells you, so you have a derivative that says you're moving in the base space. And the question is, how do you, there's a, let's see, you also have to account for, yeah, I'm not sure. Anyway, I gotta go to sleep, but we're making progress here. We're making progress. This is going to, oh boy, I think it's gonna work. I mean, I think it's gonna work, and you want to hear my little theological insight of the day?
Sure.
Okay, so the this is about if you find if you find a simple rule for the universe and it's sitting right there, what does that mean for, well, one of the theories of what that means is that necessarily there is a big distance between sort of what the universe is. No, between, okay, the universe has done something remarkable. It's gone from that simple rule to all the richness that we actually observe in the universe. And much of what it does there is computationally irreducible. So what it says is, what the universe has done is something beyond what a human, because one of the issues is the sort of, man versus God thingy, and the theory of modernity and, man can do everything, no need for God type thing, right? Is that, but this is a case where if the universe just did 10 to the 100 steps of computation, and that is far out of reach for what we can do, that is sort of a quantitative sense in which the universe has done something sort of bigger than humans can ever expect to do. Did that make any sense?
We cannot simulate the entire universe, obviously.
Well, but that's not obvious. That depends on the idea of computational irreducibility. Absolutely depends on that. It's perfectly possible to imagine a physical theory in which you could say, oh, great, we solved the universe. The answer is 42. It is a non-trivial fact to say that the universe is computationally irreducible to the point where we will never be able to figure out certain aspects of what it does. I mean,
Well, isn't it the whole point of NKS?
Yes, it is the whole point of NKS. But
so what does it have to do with theology?
Because by the time you have, the issue is the universe as it's thrown at us something that is somehow necessarily, I mean, look, the proof that the universe is somehow necessarily doing something bigger than we can ever do. I mean, imagine the future of technology, right? Imagine that, our computers get faster, our mathematics gets better, et cetera, et cetera, et cetera. And pretty soon we're in charge of the universe, so to speak. Pretty soon you might imagine we'd be able to figure everything out.
Okay.
But in a sense, again, this is not properly thought through, but in a sense, if you see a very simple rule and you're told that is our universe, it's rubbing your nose in the fact that you can't figure everything out.
Actually, is it obvious? So suppose we can create initial condition somewhere which is going to branch out another universe and run it for some number of steps, but somehow keep, so it's kind of an emulator which is going to simulate it, but it's going to keep us enough connections to it so we can observe what happens.
Yeah.
So and then we can collect the results from it. And is it obvious that we cannot do it faster than in our universe? I mean, faster in our main kind of system than it would do it on a separate branch there.
I don't think we can get a Git for the universe quite the same way. I mean, I don't think one could actualize that, because I think the issue will be if we can get a theory. One of the most obvious questions is, for example, one of the obvious questions will be, is the universe connected? Or did some pieces break off? It's one obvious question, right? And that may be very, very hard to answer. Another obvious question.
Maybe. I mean, in practical sense, probably.
Right, but we might be able to.
Not to say would be. I mean, if we know black holes, for example, don't do it, chances are it didn't happen.
Well, fair enough. But then the next question is, given that rule for the universe, can we go faster than light? Right, that'll be another obvious question to ask.
Yeah, that might be easy to answer. Well, I mean, chances are, well, yeah.
I don't think it'll be easy
two parts to it. Whether we can go if we've never been there before, and whether we can make sort of gates,
Right. Right. But I mean, that will show up in a causal graph, basically. That will show up in the relationship between the layout here, the spatial layout, which is, determining our perception. I mean, because, if this spatial layout was good, then it would be kind of our then that's that's our space, basically. And then the question of whether there exists, then the question is whether these kind of long-range connections that we see right here, whether there are ones of those that go horizontally, basically.
Well, they don't go horizontally by definition.
Fair enough, but they go.
But they can go almost horizontally.
Yeah, right. The question is whether, if those nodes are laid out in a way so that most things that go between them have, standard light cones between the nodes as the nodes are laid out, do there exist some connections that go, more horizontally than the standard light cones?
Yeah.
I mean, that's the question of whether there's faster than light stuff going on.
Right.
All right, I need to go to sleep. Sorry, I'm the practicality of
Right.
right. We kept Jesse up really late. If Jesse was still, I'm sorry to. Anyway, all right.
No problem.
Well, if you get results, that would be great, and we'd love to use whatever you can produce, because we obviously need to deploy this. All right, I'm going to go, and I will talk to you tomorrow. All right, see you guys. Okay, bye.